activities that were described yesterday, or where we picked up data that could be used for yesterday's presentation, especially about lower Drava near Belišće. You will see the location that was in the presentation of Uli. So first I will present the Kopački Rit area and what is the problems and consequences of these changes. This is something that we already all know. That's why this project is launched. So we have climate change and anthropogenic impact, hydropower plants, change in hydrological regime on Drava and Danube. Also, that was caused the change in sedimentation regime. We have increased sedimentation in Nature Park Kopački Rit, reduction of water and wetland areas that are turning into the forests, and all these natural processes are significantly accelerated. So what we wanted to establish is sustainable sediment management in Kopački Rit Nature Park in previous project and also in this project. So we have observation analytical network that is already installed, where we are measuring sediment balance, and we are trying to do some spatio-temporal dynamics of sediment in Kopački Rit by GIS tools. So first we installed measuring stations for sedimentation within the Kopački Rit Nature Park. We have also, and we are doing the regular readings of sedimentation and erosion. We also did one fieldwork campaign last week. We also wanted to create forecast sedimentation curves and comparison with historical data from the drill holes and from the historical maps of the area. And we want to forecast the future rate of sedimentation in different parts of our pilot area. That is important because we want to determine the crucial amount of sediment after which the restoration costs will exponentially increase, and it will practically be impossible to do the restoration. This is some photographs from the Kopački Rit from different parts, from north to south. We have Vemeljski Dunavac channel. We have Kopačko jezero, which is the biggest lake in Kopački Rit. With the maximum water level, it is 7 meters deep. It's relatively rare, of course. We have Čonakut channel that is connecting the, let's say, places where all boats are in Zakadaš Lake with Kopačko jezero, and then going further to Danube River. And on the southern part, we have Renovo channel, which is connection of Kopački Rit with Drava River on the south. These are our location of the sedimentation measurement. They are, of course, distributed not regularly due to the sedimentation and erosional processes that we have in Kopački Rit, and also due to the distance from walking distance from some normal locations, so we don't need to have 1 day for one station if it's too far on. So we have 50 stations in Kopački Rit for now. We will install 10 more with the DANSER project, and we covered all parts of the river wetland ecosystem. Also, we have areas with expected sedimentation and areas with expected erosion. So we are doing the readings 4 times per year, and after the weather or climate-driven events like floods or droughts. So we have 4 to 6 readings per reef of all stations. We have stations in the water. We have stations also on the land, and we are reading with underwater camera for the underwater stations, and normal readings like this in the figures for stations on the land. So let's say the results of the previous monitoring is we have entrance from Čonakut channel to Kopačko Lake on the upper part. So we have formation of this, let's say, small island in the middle of the channel on the mount to Kopačko Lake, and in 11 months this is drastically risen up, and this is even after 5 more months. So in totally we have practically 16.5 centimeters at that location in only 10 months. Now it's since vegetation already covered it, it's in the stagnation, but this happened in only one 1 year. Also, we have sampling of the rain and the surface water on Drava and Danube that we are doing continuously each month. So we will have a lot of data from that. And also we built 10 piezometers, 9 shallow and 1 deep in Kopački Rit, which are sampled every month, and we installed permanent monitoring groundwater level loggers that are now measuring for 8 years in total. And this is how this piezometer looks. They are built to be higher than the maximum water level that can reach at each location. So you can see on the right image, we put our slimmest and our smallest guy to climb like a squirrel on these piezometers to make the reading. These are some data, how the data looks from one of the piezometer, and this is some analysis from the previous projects. These are the map for one period of reading for recent sedimentation. So we build like dashboard like this. So the red places are erosion and the blue one are sedimentation. And in generally, each time we have a little bit more sediment. If we put like mean for whole Kopački Rit, we have more material coming in than coming out from Kopački Rit. We also have and built in previous years this detailed digital elevation model. This is Vemenski Dunavac channel. This is so we have whole digital elevation model from 2 time periods. We have from 2013 and 2021. So when we make a calculation, we just correlate both of the digital elevation model and LIDAR survey to see, and we also have very good correspondence with our measuring station in sense of sedimentation and erosion. So we want to continue this analysis, since this digital elevation model and this LIDAR surveys are very good for some future GIS analysis. So we already have this for even for DANSER project. Also, what we did only primitive, let's say primitive analysis of the inundation extent. So we did only for the low water level, mean and high water level. So we can also model the inundation and water level in corresponding to Drava and Danube for whole Kopački Rit. So we can make some simulations of flooding and the duration of this floods, because we also have a lot of data that is still unprocessed, but we are currently processing it for the DANSER project from 1962 to 1991, and then from new measuring stations. These are interpretation of the water flow inside of Kopački Rit from the Danube, and from which sides water is entering in all parts of Kopački Rit, and by which water level of Danube and Drava. So all this data is already stored in GIS, and it's practically prepared for some further analysis. We didn't do much about historical map comparison. We have some historical maps and we have some historical atlas from, I think, 16th century to today, but these maps still need to be georeferenced properly. It's not easy to georeference, since the coordinating system is a little bit different, but they need to now be georeferenced and then digitalized, as yesterday was shown in the presentation. So we can maybe then correlate current analysis, current data with these historical maps to see how the channels were moving and how they evolved during time. So we have now I will just show one other location that is near Drava, near Belišće, that was mentioned by Uli yesterday. So that give me idea. So maybe we can also comment on this area. It's a special ornithological reservoir Potpanj near Donji Miholjac or Belišće on Drava River. So its location is very, very close to this small city Donji Miholjac, and very, very close, around 1.5 kilometers from Drava River. And this, what you see, Stara Drava, this is the old channel of Drava of Drava River. So this is now ornithological reservoir, but for us it was interesting why there is a lake, here, and what is its connection to Drava and connection to groundwater around. So what was also a problem in the Potpanj area, we have, as in Kopački Rit, as in other wetland areas, we have prolonged low water levels, which then results with increased and accelerated eutrophication. Also increased sedimentation. That was a little bit odd for us since there is no constant water flow into the lake. So why we have more sediment each time? And we have domination of invasive vegetation, which are closing the lake, which are rapidly closing this lake. So that was the idea for the project that we started also a few years ago. So closure of the lake and loss of water areas and turning them to forests, which will then result in loss of special ornithological reservoirs, and there will be no birds inside the reservoir. So some unanswered question before we started this project was, why is there a lake in Potpanj and what is the relation of lake to Drava and groundwater? So what is actually filling the lake with water and when? Then also what we wanted to see, what is historical evolution of this lake in relation to Drava channel migration around. We analyzed some maps, historical maps, and we saw that a lake is practically in the middle of the former Drava channel. Also, we wanted to see geological or lithofacious settings of the Potpanj lake. And in which stage of the relief evolution is Potpanj? So is it practically at the end? So it's natural cost for the lake to close, or this is also a result of anthropogenic influence or climate change, so that the process of closing the lake is much more accelerated. And the final purpose of whole project was how to secure constant more water to the lake to preserve these water surfaces. Also, similar like in Kopački Rit and similar like to our DANSER project, we have monitoring of the recent sedimentation, which was not the key factor here, but we have biotic monitoring that is done by Fazos and Siniša Ozimec. We have hydrogeological monitoring, hydrochemistry monitoring, geophysics, aerial surveys, spatio-temporal GIS analysis that is currently in progress, and some restoration scenario simulation. So what is the best way of restoring this area? So the sedimentation monitoring is placed like this, 20 locations, and practically all these blue areas on the north is now practically completely dry. This was former fish pond, but now it's not used, and the only part is the southern part of the lake where we have the most of the biggest density of the measuring sedimentation stations. So this is how the lake is actually looked. And then the question was why the lake is exactly here at this and from where the water comes. So when we see this figure on the upper stream, we have this boundary between some small plants and practically whole part that is completely out of any vegetation, like in this figure, and practically in the center of this lake there is a spring. That is the reason why we have the water, and that was, let's say, our biggest fieldwork discovery. So then when we discovered this spring, this gives this area a whole new value in sense of nature preservation. So this is the center of the lake, and this spring is practically here where we put the water level measuring station. Hydrogeological monitoring is done by 5 piezometers up to 50 meters depth, and the groundwater level is monitoring for 5 years continuously through the time, and every month we are taking samples from all piezometers to make hydrochemical and isotope analysis. This is the figure from the drilling procedure, and then the monitoring of the groundwater level. This is only for the securing that our groundwater level loggers are working properly. This is in situ parameter. Here we are measuring in situ parameters of groundwater, so electric conductivity, dissolved oxygen, and taking samples from isotope analysis from Drava spring, from the rainwater on the mountain that is close to the location, and from the groundwater. We also spoke with the local water management company. They give us two piezometers, one shallow, one deep, so we can also see the relation between deeper groundwater aquifer and the shallower groundwater aquifer, Potpan Lake and Drava River. So we have practically whole system monitored and practically closing the whole system by sampling. Another sampling. And also we conducted some geophysical work. Since it's lake, it was a little bit tricky to conduct electric tomography. So we modified our equipment to do also underwater measurement. So we put the electrodes on the bottom of the lake, and we conducted geophysical ERT sections. So we can see that this blue part is practically clay. All other, this purple and red, are sands. So this is now the complete reason why we have spring, and we have the biggest resistivity in the middle. So practically the water is coming in from the middle of the section, let's say, to the middle of the lake. And this on the fieldwork card, this is everything that is left from our geophysical operator. This was the analysis of the historical maps from 18th, 19th, 20th, and 21st century. So we have, for this location, we have very good reconstruction of the Drava flow. We also have some issues with georeferencing of the maps, so that's why they are distorted. Some of them are a little bit distorted, especially this from 18th century due to the difference in coordinate system of the map and current coordinate system that we use. So what we can see in the 19th century and in the 18th century, that this is our location where we have this purple polygon, and Drava is flowing through the middle of the polygon also in the 19th century, and in the 20th century we have Drava abandoned this channel and form new channel that is a little bit distant from Donji Miholjac and from Potpan Lake that is then formed later on. So the 21st century, this is a picture from today. We have the lake in the middle of this ornithological reservoir. This is then the subsurface lithofacious section. So also what is important to see on this section is that Potpan Lake is a few meters above Drava level. So that will be important for the groundwater, surface water, and lake divide interpretation. When we saw the isotope analysis said that sometimes we have a lake is corresponding to the Drava, especially when Drava is high, but after almost 3 months, which was interesting. Most of the time, lake is corresponding to groundwater. Practically, they have perfect correlation on it. And Drava is, and when we also correlate this with water levels from Drava, from piezometers, and from the lake, we saw that lake is not responding to high water levels of Drava immediately, but only after a few months. That was interesting. Also that is happening with piezometers. This is composite diagram of all piezometers, Drava, lake, and rainwater. This is the distance of the piezometers from the Drava river. So we also calculated the distance of Drava to piezo and distance from Drava to lake to see is there any correlation between how much Drava fills the groundwater and how much time is needed from Drava water to enter each piezometer and the lake. Finally, we also did detail LIDAR of the lake. Vertical scale is a little bit excavated to 1.5, so we can easily see this old Drava channel and where is the lake. And here we can even better see how what is the Drava channel, previous Drava River channels. This is the geophysics in space, so we can see how the boundaries of the lake is practically perfectly corresponding to our geophysical measurements. And then we started to simulate what surface of the lake is filled with water by different water levels. So we also wanted to calculate how much water would we need to enter to the lake to secure, let's say, 1.5 meter of water in the deepest part, or 2 meters of water, or this is, let's say, when we have 2 meters of water, this amount of lake would be underwater, and this is between, let's say, half meter of water, this amount of lake would be filled with water in sense of future restoration. This thickness corresponds to depth of the water level, so this is with half meter, and this is with almost 2 meters in the deepest part of the lake. So general conclusions from both of these areas that are especially Kopački Rit, but in smaller scale, this Lake Potpanj also, they are very dynamic depositional ecosystems, and the changes in these environments are the changes are practically rapid, and they are happening right now. So we need to intensify the data collection and data interpretation from water level analysis, from historical channel migration, and to form enough data to make scenario of future future scenario modeling to see which would be the best restoration method. I didn't put Stara Drava and Terezino Polje and Gradac channel to this presentation since we already have this presentation in the General Assembly meeting, so I didn't want to repeat the same presentations here. So I wanted to put maybe two areas where we have the most amount of data. Also to these two areas we have we can get the data from the bathymetry surveys of our national management, national company, navigation route management company. So we can see maybe bathymetry through the years, because they are doing recently they bought multi-beam, so they have some multi-beam surveys, but most of them are single beams, and we will probably get the data from last 15 years. So that's from me for today. So let's say that this is the end of the presentation.
Okay, super. Thank you very much. I really like that you put the opportunities from what was discussed yesterday to the middle section, and I'm wondering also about what do you think about the limitations in the middle Danube section if you want to do this historical reconstruction?
I think the limitation is in the amount of maps that we have for each area. I still didn't analyze the whole part. For Virovitica, I didn't even check. Is there any maps we saw for Belišće, Donji Miholjac? We have from 16, but it's practically one map per century, so it's not that much data as they have for Upper Danube. So I don't know how much this will be correlative in the wider scale in corresponding to the Upper Danube. We will definitely have less data than them.
Okay. I'm also actually wondering, because after all, the task 3.3 is, sorry, we have questions from Sinisa. Let's go first with that.
Okay, hello everyone. I would just like to add some information following the Ivica presentations. So the FASAS is involved, for example, in Potpan in biotic monitoring. So we prepared and make a detailed survey of this area and make a digital habitat map. So Ibiza has this map, and it is a layer that really represents the relationship between sedimentation, the water surface, and the distribution of vegetation. The problem is already emphasized. It is the loss of aquatic habitats, which is connected to the birds' habitats. For example, when this special ornithological reserve has been established, we had a number of 110 bird species. During our fieldwork, we recorded 60 species. It is evident that number of mainly protected bird species is decreasing. This is the same in the Kopachkirit. FASAS was involved in habitat and flora research, and we also made one comprehensive digital map of habitats in Kopachkirit, showing the situation that it is a total flooded area and that it is a totally dry. So these maps are also will be available to use as a GIS layer in analyzing for example, this part of connection between biodiversity and sedimentation. That was my comments.
Thank you very much. Severin, I'm very curious to hear what do you think actually?
I'm overwhelmed by the workload on the work tasks you have in your project, but I thought the main goal of this workshop was the core of task 3.3 is to check whether it is feasible to do more or less the same analysis at the upper, middle, and lower Danube so that we have comparable results. Please, Julian, tell me if I'm wrong. I personally do not want to force anybody to do exactly the same that I did, but I thought it's the goal of this task to clarify this if we can produce comparable data and results, and to reproduce the method for the middle and lower Danube. This, as I understood. So there was plenty of information, but the core question is, as I understood, if we can produce similar let's say, analysis at the 3 Danube sections. Julian, what do you think to this?
Yeah, thank you very much. I saw the hand of Uli, but just to say, yes, indeed, we have to make a similar approach for all three demo pilots. It's very important, in fact, to have a common methodology. I saw yesterday your methodology, and mostly it's important to make a good choice in selecting the interpretation and the analysis of data that we have. For this reason, I guess together with Ulrich, we can do a very well job for task 3.3. This is important, in fact, to synchronize the methodology and analysis for what we intend. Of course, in fact, it's very well, Ivica present very well the diagnosis that are interested for sediments. We know that places has important role in testing the methodology of your methodology, what was presented yesterday, and in this manner we can make a very good job for task 3.3.
Thank you very much, Julian.
Sorry. I only wanted to add that Uli also knows that you will find, I guess, several maps also in the Hungarian and Austrian state archives for the Drava River. And I think there is for the Drava River, by accident, I found a lot of maps, but I had never a project on that river section. So I think there would be plenty of historical information. Uli has more experience in this area.
Yeah, I fully agree with you. Yeah.
I also just want to add something. And I think it's very important that we clarify here now that we're all together. So first of all, when this workshop was proposed by Julian, we weren't actually aware that this spatial-temporal mapping should be applied to the other demo sites. And now the question is, how do we actually do that? Because so I checked in the grant agreement, and task 3.3 specifically for Boko and for the upper Danube River. So the results will be from there. In the grant agreement, it says that we should check also and discuss on the feasibility of the methods. But where do we put this feasibility discussion, in which deliverable? Because the deliverable for the upper Danube 3.3, as far as I see it, it's some kind of a map, so real results, it's not a report. And also regarding the person months that the other demo sites have in task 3.3. So I don't know if this is the last update, but what I have here is, for example, RGN has 1.5 person months in task 3.3. Or something around that. I think you have four in total for work package 3, and this is absolutely not enough to do a feasibility study of and do this georeferencing of historical data. Yeah, so Julian, how do you see that?
Yes, Jana, in fact, we no mention any person months for task 3.3, but anyhow, we will cover this task. I will see what solution I can do for this, but for surely, because I am very interested in fulfill this task for our pilots, I have to check with our colleagues how we will find. Yes, I saw the proposal of Ulrich yesterday to make training for students, and that will be a possibility. I have to check with my friends in Bucharest, Constanța, Galați, or Iași, whatever, to see if is any possibility to attract them, because it's a lot of work in GIS production of maps. We will see, and we will solve for lower Danube with our partners involved.
Okay, thank you. Yes, Uli, please. Sorry, you're muted.
Thank you, Julian. This is exactly the point, and as I said, so I could really imagine the amount of several working months to become involved, to supervise and support, and also even pay academics. Yeah, that's a little bit the limitation. So it is not like having full salaries or something. And it's also complicated for the calculation and internal calculation. But I clarified with the Portuguese colleagues for the financial issues in the project. So I have two issues. I'm getting paid only for 70%. So I have an in-kind contribution, a significant one. And secondly, I have the issue of my daily rate, which is, let's say, 50% of my original rate, which means I need a lot of additional working time to fill out my budget. It's not a very huge budget, please, but I'm really be dedicated to the project, and I like to use the budgets fully. And that's a reason why I'm very interested to support. But we can this clarify also among us. But allow me just to coming back to Trava and of course Kopač-Kerit and Lower Trava, as I'm also of course spending many time in this region. So I like very much Ivica's presentation. I'm also very impressed on what they're doing physically, what they are measuring, everything. And but I think it is absolutely great to embed it in this wider approach and holistic understanding of the riparian landscape and the river, also considering for Danube, in particular for Kopač-Kerit, the input of fine sediment. So we definitively need to talk about the channel incisions. Yeah, so the changes in the hydrological regime. There's one nice study of Tamás Enikő from University Budapest or Bayer, which clearly says that for Kopač-Kerit, the incision is maybe only 80 centimeters for the past 80 years, but only this 70-80 centimeters of channel incision in the Kopač-Kerit stretch of the Danube causes the loss of from 280 days of inundation to 190 days. So it is absolutely significant. Each decimeter we are losing in flooding levels, in regular flooding, in inundation, time duration is really directly linked to all these parameters of erosion and sedimentation. And of course, the historical development of the main channels, yeah, in case of Kopač-Kerit, of the Vemlenský, Dunavac, and Kornakut, and also the linkage to Trava River, are extremely important. Also the function of this levee, of the natural levees, so of the causal sand accumulation on the riverbanks, yeah, when the flood wave is coming. This has to be more explored. And this nice elevation model you have now, or since 2021, is exactly what we need. In my opinion, it would be even fantastic or interesting to have such an historical analysis for Teresnopolje, to have it for Donji Miholjac's area maybe, and of course for Kopač-Kerit. Kopač-Kerit, of course, also spreads to Serbia because Kolic-Kerit, so the other side of the Danube, the entire active floodplain would be also important. Yeah, of course, we have to focus on the Croatian part, but it's a river, it's international. And this maybe for a last sentence, what also Severin mentioned, we have a plenty of historical data and maps for this whole Baranja area, and Middle Danube or Lower Drava. Even the shortcuts of meanders, similar to Tisa in Hungary, are very, very well even documented. There are many maps, and it is so nice or interesting to see also the different levels of this lake, of this Podpani Lake near Donny Michaljac. So you have this strong incision of the former Drava, and this remaining all channels. It's a kind of skewer, and you have this very narrow river bend, yeah, this strong meandering. And for sure in the former channel, you have really a clear pooling, skewering out of material. And in those depressions, Oxbows and this lake remained over and resisted over this long time period. And this finally turns to the future. What we are doing with all these systems, with these oxbows in this Drava, lower Drava meandering belt. Yeah, so we have huge problems. We have dozens of projects. Some are water replenishment, restoration. If you simply try to rise the water level, it is, of course, very important to stabilize water levels. And from nature protection reasons, it is, of course, in particular important to keep the water in those systems. However, of course, we have to understand it, how it is interlinked. And I think it's not, let's say, the choice, the right choice, simply to build some structures to rise the water tables. We not talk about mires or peatland or something where it is absolutely crucial to rise water tables, yeah, to regenerate the books and fens. In floodplains, I think we really have to look for the river, for the incision of the channels, of the whole system movement of incision, erosion, accumulation. This is exactly also what Severin is doing with his work. And this is really, in my opinion, a remarkable point, how to join your excellent fieldwork experience also on the sedimentation issues, everything what you do with the measurements, to this more holistic approach of understanding of the riparian landscape, yeah, former meandering. And here we need also time steps to see the development, and this is very fascinating. And I would even go, maybe not for all three areas in Croatia, for middle Danube, but we should see where it is the most promising. But it will be definitively support strongly this work. Thanks.
Yes, Severin, please.
Yeah, what I would find very interesting for the whole project, for the comparison of the 3 Danube sections, is if we could finally have data on, let's say, on the composition of the different types of water bodies in the 3 study sections, and differences in the intensity of hydrological connectivity and on the erosion and deposition processes, as I showed yesterday. So how it's only an aerial, only the aerial extents are measured by this. For the Upper Austria, we have an idea how we can also calculate volumes out of this, because we also have historically 3D models from the floodplain. But nevertheless, I would think this would be very helpful for the understanding of the differences and of the different problems in the along the Danube River, and to get the first time to get an idea about the fluid dynamics, the role of fluid dynamics, and also about the consequences of human interventions on the water body types and on the erosion deposition processes. And if we could do this in a analogous way, this would, I think, also result in a wonderful scientific paper, because we never have done this until now. We only focused on single sections like Kopacki in Vienna or in Upper Austria or Morava River. I also did this for the Red River in Vietnam already. But along the Danube River, this would be really interesting to see if we could synchronize our approaches.
Okay, thank you. That is really a very nice point. I will probably contact you later so that we can have some type of conclusion after this discussion and gather all the ideas and have it at least in one document. So even if those ideas cannot be implemented directly in the project, at least that we have ideas for future projects. Okay, super. Maybe, Julian, please.
Yeah, thank you, Severin. In fact, yes, indeed, we must to give diagnose for sediment balance and also human intervention. For this reason, we choose these pilots where are human intervention, where the sectors are in natural condition, and indeed we must to answer to the question, why are so important the sediments? And these maps show us, in fact, very well spatio-temporal working of phenomena. It's very important, in fact, and the analysis based on this GIS manner, it can help us very much to answer to this question. It's not so easy to convince citizens that the sediments are important. Yes, are important for all aspects, biodiversity, socio-economic aspects, cultural aspects, and so on. Thank you very much. This I want to state.
Uli, please.
Yes, just one sentence. And it is also promising looking into the future. It is extremely important. We have so many, I not want to say wrong restoration activities in the field of meandering rivers, for instance. Yeah. So we have money, we have projects. We have a very strong, quite good situation also for large scale restoration projects, but we are lacking very often exactly in this connex to sediment and sedimentation and erosion, of course. And therefore, this is not simply pooling working in the past, but I think it has really great implications looking forward for restoration and management, of course, in those areas.
Okay, thank you. Before the coffee break, I just want to reach some concluding remarks about the feasibility, going back to the topic of the historical reconstruction. So what Ivica said about the historical maps available for the region is that we have one map for every century. Then Uli also said that we have regions with a lot of data, but overall, from yesterday's presentation, is it then enough to have this one historical map per century as a feasibility? No. Okay.
No, it's not enough. But as already said, for at least for the lower Drava River, I guess there's a lot of historical maps available. And for Kopacki, I guess there are also more maps available. So I only found them by accident, but I was surprised what is available.
Okay, this is very interesting. So this is for lower Drava and for Kopacz Kirit. Then is it possible that maybe I don't know, maybe Ivica is not aware of this data? Is it easily accessed? Or yeah, this is interesting that we continue then the discussion and maybe send this data among each other.
Yeah, best available are the data from the Hungarian National Archives, because most of them you can see and they have scanned it and you can see it already online. In the Austrian State Archive, it's not that easy, but maybe even in the provincial government of Styria, of the province Styria, there might be some maps. So this needs a little bit. I prepared a book with almost 1,000 pages of historical maps for Austrian rivers. Some extend to the some extend also to the lower Drava or to the German Danube. But this was outside of Austria. It was never my focus. But from then, there I know it's online available. This let's say this book with all the data, and this provides some information where you can find and which archives you can find historical sources you need. Of course, it's in a PDF in German, but you can easily translate it nowadays with some tools.
Yes, super. Then maybe I just have one question for Ivica then. Is this historical data that we were talking about that is available only once a century? Is this relevant only for the lake with the high ornithological importance, or?
Probably yes, because we didn't put too much focus before on this on historical mapping, since we were concentrated on this establishment of this monitoring and surveillance station. So we didn't do much of the historical mapping. So we need to just search the internet and to see in the local archives of the counties, or maybe to ask some Hungarian colleagues to see what is even what is available online and what is available maybe in the paper in the local archives for each area.
Okay, super.
Yeah. I've just uploaded my book. Of course, it's more or less for the Austrian rivers on the cloud and for day one. But at least it gives some impression where you can find maybe also in Hungarian archives or so some information.
Okay, super. Then the conclusion would be that it is feasible using these Hungarian national archives for some regions, maybe exactly for the lake where there is interest in doing the historical reconstruction, there might not be, but for other parts of Lower Drava, it could be feasible. Okay.
Yeah, and often you have to look in provincial archives and in the archives of the water authorities, of the river management authorities. They have their own archives normally. I do not know how it is in other countries, but I guess it's more or less the same, that they have their own small archives with historical data, maybe.
Okay. Super. And then this is quite related to my previous question, how we are going to report on this feasibility that we're now talking about. Maybe it could be something very simple, just saying in these regions we have enough data to apply the method, and listing all the available data so that it's easily accessible and findable after the project when such a study would be done. Okay. Then we're now right on time for the coffee break of 10 minutes. And we're continuing with DDNI's presentation just after that.
Okay.
Okay, super.
Mhm.
See you in a bit.
Să te audă și Matei.
Da, da. Da, și microfon.
Okay, welcome back. This short break was quite fast. And I think we can move forward in a couple of minutes. And I'm really looking forward to see the presentation from Didi and I once everyone is back, and that we continue our discussion with the lower Danube section as well.
Can you hear us?
Yes.
Ceva în regulă. Da, da. Can you hear us?
Yes.
Vezi ce device ai. Așa schimbă. Trece pe real. Căștile și le. Și tu mă auzi direct. Sau
Yes, we see your screen, Julian.
yes, thank you. I have to change the office because my conditioning there was broken
Oh,
and doesn't work. It's criminal, and now it comes somebody to mount. Okay, but shall I start?
yes. Whenever you're ready, please feel free to start.
So, regard. Mai important, e aceeași. Okay, so demo 3 pilot sites. I will try to make an overview of all pilots and not at least some words about sibling sites that are on demo 3. In fact, the lower Danube and Delta demonstration is focusing on restoring, protecting, and enhancing sediment balance. This is very important in our view because we have critical stretches on the lower sector of the Danube, but not at least in Danube Delta we have to face with sediment crisis. Incorporating also in our demo site, incorporating diverse sibling sites, which are not far from the choose places. Objectives, as you know, I not insist too much, but this is very important to develop models to predict sediment behavior. We must to integrate sediment and the infrastructure management of them and to identify sustainable solutions. For this, I consider that this task is in fact very important. And the connection of this task with demo sites, with the work package 4, it's crucial for the DANSER project. For the involvement of local actors, we have to organize some living labs together with the local consultations and co-creative testing solutions. And for sibling sites, these are very important to come on the table with a very well theory. Our demo encompass, in fact, iron gates, Belensky marshes in Bulgaria, but this is in connection with our Danube region. Also Friendship Bridge and Danube Delta. Because we discussed before a little bit about the involvement, in demo, practically we have a lot of work to do, and we must to prepare very well the implementation. For this reason, we can make some works, what we have to do in restoration planning, in sediment monitoring, hydrological analysis, biodiversity studies, to do into the task 3.3. It's a kind of strategic and I think will work. We have partners from Bulgaria, RUNI and EAEMDR, and from Ukraine, HD is missing, I guess, the Hydrological Institute from Ukraine, and partner GBA, which is very involved into modeling part. For the modeling on coastal part, our colleagues from Constanța, from Grigore Antipa Institute, they will be involved, and they have already experience on coastal troubles with the sediments, and they will do this. And now for Belensky marshes modeling, it's a part where RGN and Boku University, they will be also involved in the work package 5, I guess. How the pilots are split? As you can see, we cover entire Danube, lower Danube sector. And what is interesting, because the pilots are managed by different authorities, like in Iron Gates, National Agency for Natural Protected Areas, which is very interested in what we have to do, and not at least is one state company hydroelectrica, which produce electricity, and you can imagine that our job it's very well appreciated. The second one, it's also a national park, Belensky Marshes, Nature Park Persina. The bridge, the friendship bridge, is managed by AFDG, which is our partner. AFDG, it's administration for Lower Danube navigation, and they are very interested to have in good conditions for navigation. And the last pilot is under administration of Danube Delta Biosphere Reserve Authority. I put this to emphasize that most of partners are inside the DANSER consortia. Even the Ministry of Environment, in fact, which has all of them, it's involved in DANSER. As I said, we have 4 activities, mainly hydromorphodynamic modeling, sediment management from dredging. It's important to know what we have to do with sediments. Baseline sediment balance analysis. In fact, this we must to state from our project. It's very tough to obtain without indicators, as Severin and Ulrich show already. The analysis based on spatial temporal informations are very important in our approach. Yesterday, when we start, we said that we must to start with orthophoto. We have such orthophoto made in 2018, and you have in the slide presented a picture from that period. Speaking about ancient maps, we have representations from 16th century, from Diogo Homem, but also a very good map, a very good representation, graphic representation for Wallachia, Serbia, Bulgaria, Romania, made by the famous cartographer Mercator. And this original can be found in the Museum of Maps in Bucharest. We find also reed bird's eye view of the Black Sea and Crimea during the Crimean War. In fact, a panoramic view of the seat of war in the east. The focal point of the conflict was exaggerated like nowadays, and was needed to have maps for this Russian Empire. Was done a lot of studies, and we have maps from the 18th century, very early, and as you can see, a map of Ural and Black Sea from 19th century. These are on coordinates and can be found in some collections, also on internet. the first map what we have to take into consideration is the 1834 map made by Russians survey. It's the entire Cape Kaliakra to Odessa. You can see a detail of Russian map, which show very well the routes of the Danube arms in the Danube Delta. You can see the Sulina Canal before to be arranged. Because I said about arranged in 1856 when was created European Commission of the Danube. Captain Spratt was producing a very impressed map and very rigorous for topographic survey. In fact, this can be the first document what we can take into consideration. Also, the mouth of Sulina, and this is one challenge because we have representations of Sulina from 1856 till nowadays. For the European Commission of Danube was produced, as you can see, 56, 61, 76, 92, 1904, 1921, 1925, 30, 38. With representations after 1950, we can create the entire frame for the Sulina. It's very important, in fact, to make connection between sediment during the different periods and the evolution, and also the anthropogenic interventions. Of course, we have from 1985 military maps, as you can see in this mosaic of some maps, where the situation is practically still in some parts in natural conditions, and we can make appreciations and interpretation of evolution. Few words about pilots. In fact, Iron Gates, you can imagine, is not just a barrage that you can see in the center of this image. The barrage has 27 meters difference of water level between upstream and downstream. It's a huge amount of water and sediments flowing on this. We have to create a model for this area, and we established to have from all three parts of the Iron Gate complex. Not at least, as you can see, the second objective is to have assessment of interactions between flows, sediment, and hydrotechnical works. It's quite difficult without indicators and analysis. Here in the first pilot, we find interesting map of European Turkey made by Carl Fleming and Friedrich Hamke in 1870, which can see island on the Danube. In the center, it's marked by red color, Adakale. You have two aspects of Adakale in 1930, and in right side, how was life in 19th century. It was flooded in 1970 by the waters of Iron Gates, and entire island is under the water. And the population was moved downstream on Corbu Islet. Belensky Marshes, it's one sector very difficult for navigation. It's necessary to appreciate evolutions, and I'm very happy because Task 3.3 can create possibilities for interaction between underground water and the Danube waters. It's very important, this sector where the dynamic is very, very much, as you can see in these pictures. Also a picture of Belensky Marshes. And nowadays I took from the AFDG website critical points, and you can see now what are the critical points. The depth is very near to the critical situations where navigation can't be done. 180 centimeters, practically the navigation is stopped. This is very important. In fact, in 2003, when we have historical water levels of Danube in Kalnovets, there was 180. Now is 222. It's not far away. One important map for this sector is known submarine map in 1864, was published in Bucharest, and is possible to find on internet. It's a good one. It's good one, and we can use, as you can see on the screen, with a lot of infos. Three maps, as I said, about submarine map. In the middle, there are some firing plans made by the army for the First World War and after the First World War. We have in our institute these firing plans for the Danube Delta. And last in 1985, it's a topographical map made by Geodesy Institute in Bucharest. These maps can be attracted and digitized to take infos, and of course to change referencing, because that was made in different projections, cartographic projections, and different datums. Friendship Bridge, you can see the picture and what we are looking for to have in good conditions the navigation under this bridge, and to be saved, due to that the islet have a very dynamic situation in the waters. For this reason, we have taken into consideration the monitoring between kilometers 495 and the kilometer 510. We can find good infos also on open maps on internet. We have geospatial interventions and can be also used for Danube flood risk atlas. We use it the OpenStreetMap as a background for putting the infos. Yes, also we have to add some interpretations from Copernicus. I put exactly in this second pilot for the Friendship Bridge. You can see how is dynamic in different aspects in infrared, in false color. You can see better the positions, but not at least important infos you can obtain from normalized difference water index, which is important to know how is the situation for the Danube Bridge. In the fourth demo pilot is Danube Delta. We focus in our analysis for Chatal Ismail. This has this part is a fork of the Danube in two, in Chilia arm and Tulcea arm. And it's a very dynamic region, as you can see in right side on the hydrotechnical work what was made by Charles Hartley in the beginning of the 19th century, 20th century, sorry. Yes, it's important to have this model, but also some aspects what we are interested, and not just us, also Danube Delta Biosphere Reserve to see the activity of dredging for assure both the navigation depth, but also to assure the flow of matter, of energy, of for the Danube Delta, we can find some aspects in some graphical, also on internet, but also for the Danube, as you can see, for different periods of time. You can see from 1782, different islets was represented on the graphics. But as I said, one important document is submarine map. In the beginning of the 20th century, we have this map of Danube from Ulm to Danube mouth. We have in our institute in GIS representation, and can be also used. Fragment from what I said, firing plan. One very good map is made by AFDG. They have made maps for navigation from the beginning of the 20th century, and the Commodore Cătuneanu was take the fifth of golden medal Paris with his representation, and this good practice continue. We have some maps, as you can see in pictures from 1935, 1956, and 2003. These are printed and also are good representations that can be used. AFDG also has in GIS in their communication for navigation. The maps is a portal that they use for navigation, and every ship has opportunity to reach. I said that from European Commission of the Danube, the entire atlas is in our hands, and we can use it very well in good conditions. Of course, for the Danube Delta, we are happy because also after that atlas in 1856, but printed in 1880, we have a special topographical survey. Is a hydrographic map was made under the Grigore Antipa coordination. The engineer Vidrașcu was involved and create practically a very, very good methodology for representation of depth. Practically, he used a very interesting unit, named hydrograd, which represent 10% of difference from maximum registered by last 100 years and minimum. Using this hydrograd, you can see how much is covered by water on different water levels. It's a good interpretation and was very useful for different economic purposes, like fish culture, like reed harvesting, agriculture, forestry, and so on. And not at least for the navigation, where they use the word étiage for their representations. In 1950 was realized a map of Dobrogea, and also we can use it for the sector of the Danube from Călăraș to Black Sea. This I want to emphasize. Please address questions. There are also our colleagues I saw in this workshop from AFDG. I saw, and I thank you for their participation. I saw from Grigore Antipa Institute and from INEHGA. That's from my side. Thank you very much. The floor is yours.
Thank you very much, Julian. It was really interesting to see also what's happening in the lower Danube. Any questions? Yes, Severin?
As I understood them, there are a lot of promising cartographic sources, as I see from the 20th and from the 19th century. You said that the first more precise map is from 1834, I guess, an
Yes.
Russian map. I'm wondering if you know maybe I have saved it as a Russian map from 1771. But I have no name of the author. But if I could share the screen and show you this map. So I guess I have to. Somebody has to kick your presentation out that I can
Yes, yes.
share something like this. So then I would show it. Probably you know it. Maybe can you see it now?
Yes, yes, I see it.
Maybe
I
you
know this.
yeah,
This
you
map.
know this. I just
It's a
wanted to.
new version. Yeah, it's a new
Yeah,
version of previous one.
Yeah,
No
this is
other surveys was made, but was improved. The map.
yeah. I note it here that it's from 1771, and there's another one from Tiberio Groparu from 1778. Rather similar one I have found on my computer. I only wanted to show it to you if if this might be useful. Yeah, I guess from particular on from the Sprat map from 1856 onwards, there's a good basis, I guess, to capture all the fluvial structures that are needed. But the area is huge. It's
Yes.
really a huge area. And what I also wanted, what I have forgotten to say in the last presentation, I georeferenced the Bassetti map that unfortunately only reaches towards the downstream end of the Iron Gate, but if the Austrian National Library agrees, and they will agree, I can of course provide the georeferenced Bassetti map for the different Danube sections, which means, for example, for the Kopacki Rit.
Super.
Thank you very much.
Mhm.
Any other questions?
And
Then
I
maybe also
only
yes.
wanted to add that for me, of course, this is a total interesting, the lower Danube, totally interesting because it's so different from the upper Danube. So this would be really highly interesting to compare it if we can manage it to analyze it in a similar manner.
Yeah, indeed. It's completely different. Just to agree with Severin. Yes, if important in upstream is the size of grains, here important is to have a balance between the sediment input and output. And also to have exactly the quantity of sediments in the water when it's summer. Like now, it's very, very hot and everything can be burned. You can't imagine a life without sediments in the water mass. It's very important because these assure low temperature for the water. This is very, very important, and also very important is to take care by the connection and connectivities of sediments balance.
I think it would be also interesting what we do to make connections to major flood events or to different climate phases. As I have yesterday showed, that we always see the peak at the end of the 18th century in some fluvial metrics because of the climate changes. And we see then often in the early 19th century, we see how the river develops back to a former stage after this peak in the climate-driven peak in the late 18th century. And but if you have the history, you know the timeline of larger floods, how this information can combine. For us, it's very important to understand why we have major channel changes.
Yes, indeed. We have one mention in the beginning of the 20th century, 1903, if I remember well, when was the maximum floods, what was registered with around 20,000 cubic meters per second. And after that floods appear first nucleus in San Giorgio mouth. Before this was an estuary, and afterwards appear some islands, which now is practically covering the entire mouth of the Danube. It's very interesting to see the evolution there on the mouth of the Danube. Nowadays there are other morphological changes and change effectively the currents in that area. And fishes like shad, like Alosa pontica, can't enter for their migration. It is the same migration like salmons. And they can't enter because changes in the Danube mouth. Such kind of things are very important to present because sediments are very important for both for nature and for human activities.
As I yesterday said, at the upper course or similar to also in the middle course, I guess, of the Danube, if the external framework conditions for in a catchment of the river doesn't change, so we expect a ratio of 1:1 from erosion and sedimentation, because otherwise the river would develop a total different system. And if the ratio is disturbed, not 1:1, it's because of climate change, runoff change, because of human interventions, or land cover change in the catchment if you have land clearance or so. But in the delta, I guess this ratio will be by nature different because it's normally a deposition zone. So I guess.
Two aspects. I want to continue, in fact, but of course I don't want to make just a dialogue between you for everybody. In fact, what I want to say, we are in a climate change. The ocean water level is increasing, not too much, but enough, 3 millimeters. In our case, 2-3 millimeters per year, and the slope is decreasing. The slope is decreasing, the speed of the water decrease, and the sedimentation is bigger than before. This is one aspect, and the second aspect, we are in the transboundary region. And you can imagine when the flow of Danube waters is going on the one country or other. It's difficult, and for this ratio, what you mentioned, yes, it's very important to have in our interpretation. Thank you.
Thank you very much. I think this workshop was quite successful for the very short time that we had to organize it. And I'm really happy with the discussion that was going on both yesterday and today. And yesterday we had a few external PhD students, which was great. So I just wanted to finish off with a quick discussion on what might be the continuation of what we did now. And that maybe we can do something like this again next year with some earlier preparation and really to try to include more students, because that was quite interesting. But I want to hear your opinion on this, Julian. And of course, Severin, who is very much involved. And thank you so much for all this material and the presentations from yesterday. And I thank DDNI and RGN today as well for preparing these presentations. But yeah, I really see that we can do something about it. And also there were some discussions earlier that we can that we need to connect what we're doing here with other work packages, such as work package 6. So maybe then for a future workshop we need to think about that as well. Yes, Severin?
Yeah, I think it's worth to keep be in touch and to make a second workshop on that. But this makes only sense if there is already something at hand made, so that we do not start from the scratch on. But I want to say, do not hesitate to ask me if there are some certain questions. I think I gave a kind of handbook yesterday, also in the article. But there are some practical things that might be of interest also, or maybe because of archive material, I have also a little bit overview over the archives in Eastern countries. But even more so, I guess Uli has also good insights into the archives. Yeah, this I wanted to say.
Yes, Uli, please.
Yes, I also want to conclude somehow. Julia, an excellent presentation, and for sure the Delta and Lower Danube is also of particular interest in this matter. And there are more and more sources. When I remember 10, 15 years ago, so I was also looking for much more historical sources. But so you present a lot of pilot sites, a lot of sibling sites. Also Lower Old would be interesting. The reservoir stretch, Siret Brut is very nice, important contribution of fine sediment into the delta region. So finally, of course, we should also discuss where it would really make not more sense, but we must, of course, look for some particular stretches which we can elaborate. Yeah, but I really want to push it. I know for the Danube Delta there are some nice publications for the historical development, but I think in particular for lower Danube, for the islands, but also for the whole geomorphological fluvial process of building the large Pryla Islands, small Pryla Island, this is so important and was never really systematically explored. This is, of course, a kind of meta level and scale question of scaling. And this is maybe finally what I want to push, or what I want to clarify, that we need really type-specific sizes of assessment stretches and regions. We had this discussion in the GDS or the HIMO stuff at all. Of course, I mean, it makes not sense to have also for lower Drava or Danube, middle Danube. So we need really sufficient sized areas to be explored and analyzed. Yeah, so therefore it doesn't make so much sense maybe to look at one particular side branch or Balta Lake or something. So it should be really from the understanding, from the also that our perspective and the duration of our project. Of course, it must be fit. But so for lower Danube, often the people neglect the dimension of everything. So maybe this would also require some more specific approach. But again, I'm extremely fascinated for lower Danube, for instance, the different fluvial landforms. What Severin mentioned, all the types of connectivity, they are partially different. The shallow floodplain lakes are unknown on Upper Danube, so we are totally it's a terra incognita for the people from the alpine regions, from the upper Danube. So this is a fascinating issue also to bring all upper, middle, lower Danube together, and that's this nice idea behind. And well, I suppose, or hopefully also Nikolova and Severin, that we can maybe draft a little bit, let's say, the framework for this option and possibility. And of course, Julian, you have a lot of partners in for Lower Danube and Delta, a lot of interests, a lot of stakeholders and partners, maybe also very interested partners. Final sentence, of course, I mean, theoretically, Nikolova, as you mentioned also that some students attend yesterday, not in best case, but even if we can encourage also people from the countries or from the middle and lower Danube to join such a team for elaboration would be great. But others on the other side, if you have clear interests, partners are in particular interest to do it, also to share time and to provide time, it would be nice. But I'm extremely open together with Severin and Nikolova to frame some possible and potential analysis for this particular DANSER project in the frame what is possible. Of course, not what is not possible. This is a different project or something maybe for the future. Thank you very much.
Yeah. Very, very good. I come. In fact, yes, is necessary to work in not in parallel, to work together, because this work package is for preparing, and demo site is for implementation. And for this reason, we must do, even if we start a little bit separate, we have to join. And this workshop, what can be done in the end of the year, it's very well, because also the teams in demos can integrate better, and also to come with work package 3 together to stay and to put on the table something important. What is my request to Diana, to Nikolova, and Herman, of course, is for not tomorrow, day after tomorrow, to have in that 5-minute intervention for advisory, to present these aspects that we made already. The integration between preparation and implementation. This is very important because the advisory board, as I said, there are very good experts, all of them, you know, Anthony Edward from University of Paris with large experience, not just in Danube Delta, in geomorphology. Liviu Josan from Woods Hole Institute is one from known geomorphologists. Also from Delta Res, Niels is the expert on sedimentology in the Netherlands. They are a little bit more advanced in technologies for monitoring. Also from Portugal, Maria Durao is involved with this context. I thank you very much. I stop here.
Thank you very much, Julian. I will make sure that I note this down for the advisory board meeting. Thank you. And so again, thanks everybody for participating. And I can conclude now this workshop, today's workshop. And yes, expect from me soon a link with all the presentations, maybe a short summary from today with minutes from the discussion. And I will see you again tomorrow on the Work Package 3 meeting with few important points to discuss. Sorry, a lot of meetings with me this week, but yeah, it's exciting month with reporting of what we have done in the past 6 months. Yes, Julian?
Just
Okay.
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 Okay, thanks for organizing and see you tomorrow, I guess.
see you tomorrow.
Thank you.
Thank you.
Okay.
Thank you very much. Yes.
Ciao.
Thank you. Bye.
Ciao.
Thank you. Bye.
Ciao.